Okay, in this lecture we're going to be going over chi-squared hypothesis testing when you have unequal proportions for the expected frequency. In this particular situation, this is real data on Baylor students and their use of Chromebooks, Apple computers, and Windows computers from a couple years ago. 505 business students completed this survey. They responded with using Apple's Windows or Chrome operating system. Conduct a chi-squared test to determine if the distribution reflects is independent of the national market share. In other words, does it follow the national market share or does it not? With a level of significance of 0.01, can we conclude that the data differs from the national market share? So, first of all, what we did here, I'm going to get the scratch sheet out right here. Put that. Okay, so I've got my national market share right here, and the national market share of individuals who use Apple computers is about 30%. Individuals who use Chromebooks is about 5%, and individuals who use Windows machines is about 64.5%. So in order to determine the expected frequency, remember the expected frequency, all of the expected frequencies have to add up to the observed frequencies. So if we have a total of 505 individuals who took the survey, we need to know what should we expect from those 505 people. This is a really simple problem. All that we've got to do is do 505 multiplied by the percent, the national market share percent for Apple, the national market share percent for Chromebook, and then also the national market share for Windows. And if we were to do this slightly differently, point 0.3, 0.0534, or actually 0.05, let's just do 0.05. And then 0.65. And we were to do the same thing, Control C, we would put these values in instead. So if we rounded it off, we would, instead of having these values right here, we would replace them with this, and that's perfectly fine as well, to have decimals in there. So, frequency observed. So now we're going to take these expected frequencies right here, Control C, and we are going to put them in right there. And let's just go ahead and copy this entire chart, and let's spread it out a little bit. So we've got the observed and we've got the expected frequency, and now let's work out the rest of this. In order to calculate chi-squared, we're going to take equals the observed frequency minus the expected frequency, and just drag that down without formatting. And then we're going to square it, equals this, square, and I'm going fast because we've already done this one time before, so I want to focus more time on what's unique. And then equals this divided by the expected frequency, which is right here. Fill without formatting, and then last but not least, equals sum and we've got the chi-squared right there. Now if we want to know what is the percent of chi-squared, we're going to take each individual observation's contribution to chi-squared, and we are going to divide that by the total of chi-squared. So what this tells us right now is that each one of these contributes a little bit to this chi-squared value. This one contributes 68%. Okay, so basically what we're saying is, let's see, what is that? Apple computer contributes 68% of the information, or 68% of the chi-squared difference score, compared to all the other ones. So Apple is really the biggest one. Apple is the one that deviates the most from the national average, or the proportion of the national average. Well, Chromebook is actually pretty spot on. It contributes almost nothing, while Windows contributes 31%. So there's two pieces of information that you need to know in here. We're going to highlight this in yellow, and we're going to highlight this in yellow as well. Next, so these are both highlighted in yellow to indicate these both are different than what's expected. Both of these differ from the known national average frequency, or the known national proportion frequency. And what is it that they differ? How is it that they differ? Well, individuals, I'm going to highlight this in red. This right here, these are the difference scores, right? The difference scores, and I'm going to highlight this difference score in green. And the reason why I did it is because Apple computers, Baylor students, have their representation of Apple computers and Apple operating systems is a lot higher than what's expected, while Windows computers is a lot lower than what's expected. And so when I put the green and the red means that there's a deficit, green means that there's a surplus compared to the observed, when you compare the observed to the expected observations. And so these are just a few little things that I do to help remember what's going on. So I'd encourage you to make note of that as well. And it's really easy to just keep up with that. So I'm going to put that in yellow, and then I'm going to put this one right here in green, and I'm going to put this one right here in red. Oops. Just to remember this. Next, let's take a look at this. And so we do have the chi-squared value, which that's a very high chi-squared value. But let's look at this whole situation. First of all, what is the independent variable? And that is operating systems. We have a total of 3 operating systems that we looked at, and the dependent variable is the count of the individual's preferences. So the dependent variable, these numbers are dependent on what categories are available to them. So they're going to be in one of these 3 operating systems. Also, what is it that I want to know? I want to know, does the frequency of observations of Baylor business students reflect the distribution of the national market share? And we already demonstrated how to do that. We found the national market share. We found the national market share right here. And we found the numbers that would correspond with the national market share. So now we are comparing the actual observed values to the expected values based on the national market share. Okay. So now, what is it that I do for the null and alternative hypothesis? Once again, just like the previous question, you come all the way up here and you can find the null and alternative hypothesis example. And you say, okay, here is a null and alternative hypothesis example for when you have different expected frequencies. So I'm going to copy this and scroll all the way down. And I'm going to paste it right there. Notice it's very similar. There is no difference between the observed sample, or the number of observations in the observed sample, and the expected market share values. And once again, there is a difference between the observed sample or the number of observations. I really should say number of observations in the observed sample and the national market share expected values. So I'm going to copy this. It just provides a little bit more precision the way that I just updated it. There is not a difference between, and there is a difference. And so I have those null and alternative hypotheses there for you for a reason. So that way you can copy them and use them. Next, what is the level of significance? Right up here, the level of significance is 0.01. What is the test statistic? Chi-squared. We're running chi-squared. And then as far as the tail, chi-squared is always upper. Alpha, once again, 0.01. Then what's the degrees of freedom? The degrees of freedom is the number of categories minus 1. There's a total of 3 categories. So it's the number of categories minus 1, which gives us 2. And next, for the critical value, we're going to use the Excel formula to determine the critical value, just because it's very easy to do this. So I'm going to use the equals CHISQ dot inverse dot right tail and put the alpha level 0.01, and then I am going to put the degrees of freedom, which is 2, and that's going to give me a chi-squared critical value of 9.203, which I'm going to just paste that. 9.203 dot 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 dot. Okay, so now we've got the critical value. Okay, and once again, what is a critical value? The critical value is that threshold, which we've got the critical value right here. This is that delineating point. Anything to the left-hand side, if I get a calculated value to the left-hand side of that critical value, then I fail to reject the null. If I get a calculated value to the right-hand side of that critical value, then I reject the null hypothesis. And so that's what I'm writing right here. If chi-squared calc, and I'm going to put this down here, is greater than 9.210, then we're going to reject the null hypothesis. If chi-squared calc is less than or equal to 9.210, we're going to fail to reject the null hypothesis. And so we've got that right here. Next, formulate your decision. Two ways to do this. You can compare the test crit to the test calc, and we've got the calculated value. How did we get the calculated value? That is a really good question, and remember, the way that we got the calculated value is we added these numbers right here, the contribution to chi-squared, in this fun chart, which is also right up here. So frequency observed minus frequency expected squared divided by frequency expected gives us all of these individual values, and you add all those individual values together, and this gives us chi-squared, or better yet, chi-squared calc. And so I'm going to copy and paste this. Chi-squared calc. There we go, chi-squared calc. Chi-squared calc, and so we've got a chi-squared calc of 317.46, a chi-squared crit of 9.210, and when you compare the two of them, first of all, the probability of the chi-squared calc is less than 0.001. How did we determine that? We'll get to that in just a second, but just based off of the critical and the calculated value, when we compare the two of those, we know that we're going to reject the null hypothesis. So what's the p-value? So the p-value is 1.16 to the negative 69th. And what I'd suggest is put p, or the probability of this occurring, is less than 0.0001. And how is it that we got this? We used, once again, the Excel formula. I love the Excel formulas because they're just quick and easy as long as you know how to use them. Just keep a library of them and you'll be good to go. Chi-squared dot dist dot right tail, and we need to put the chi-squared value, which is going to be 317.46, right there, and then we're going to put the degrees of freedom is going to be 2, and that's going to give us 1. Yep. So if you round that, 1.1599 or 1.16 to the negative 69th. So that's how you calculate that, and we could do the same exact thing with the critical value. If you want to see the probability of the critical value, let's go look at here with the critical value of 9.210. The probability of that, look, is 1%, or 0.01, which for some odd reason I have 7.815. Let's do 9.210. So just to show you, this formula does work because we specifically said we wanted the alpha of 0.01, and so when we have this value right here, we've got an alpha of 0.01. So, what is your decision? We're going to reject the null hypothesis because the chi-squared calc of 317.46 is less than the critical value of 9.210. 9.210, or sorry, chi-squared calc of 317.46 is more extreme than the chi-squared critical value. Chi-squared calc is more extreme than the chi-squared crit value. So, and that's the reason why we reject the null hypothesis. And there's a very small probability of this actually occurring, assuming that this is assuming that before anything happens that they are going to be the same, or that the null hypothesis is true. Remember, this p-value always means assuming that the null hypothesis is true, this is the probability of getting the result that we got. So obviously they're different. So what is the effect size? How much do we know about this? Like how noticeable is this difference? And the way that we do this is we take chi-squared calc, so 317.46 divided by the number of observations, and how many observations are there? Let's see here, equals sum. There's 505 observations. Just look at something really quick. Yep, 505 observations. And when we've got 505 observations, multiplied by the degrees of freedom, which is going to be 2. So if you take this formula right here, this is saying, hey, take the square root of 317.46 divided by 505 multiplied by 2. Okay? And so what is that? And it's going to be 0.5606. So I put that right there. This is the effect size, which means absolutely nothing to you unless you know how to compare it to, you know, small, medium, large. How does this compare to small, medium, or large? There is a chart, but more important than the chart, I would suggest using this formula and saying, okay, is it close to a small, is it close to a medium, or is it close to a large effect size? And I'm going to start with a small. So we've got 0.1, 0.3, or 0.3 and 0.5. And for how many degrees of freedom? We have 2 degrees of freedom, and so we've got equals 0.1 divided by the square root of this, and I'm going to just put a fun little $sign there. And I'm just going to drag it. And so this is small or less, medium, and I feel like, yeah, I definitely messed something up there. Hold on 1 second. I knew that I messed something up. There we go. Let's do this again. Drag it down. Small, medium, and large or greater. So we have an effect size of 0.56. How does the effect size of 0.5606 compare to the 3 of these? Okay, it's larger than this, so let's move on to medium. It's larger than that. It's larger than this. So therefore, because it's larger than what's considered to be the threshold for a large effect size with 2 degrees of freedom, we know that it is going to be a large effect size. So, right here, the effect size of 0.5606 is a large effect size compared to the threshold of 0.35, which this is a threshold right here. So this right here is the threshold for a large effect size. The difference in this result is very noticeable even without a large sample size. In other words, it's easy to see that there's a difference. Okay, then interpreting the effect size, we already did that. Now this is something that's new that we didn't talk about in the last lecture. Interpreting the percent chi-squared. We already did that a little bit earlier, and basically we're saying, where is this significance coming from? Just because you have a high chi-squared, that's not enough. You need to say, we have a high chi-squared, the chi-square indicates there is a difference. The percent of contribution tells where the difference comes from, so let's do this. And then last but not least, the difference score between the observed and expected frequencies indicates how it adds to the, or how it contributes to, how the difference in the category contributes to the chi-square score. So in other words, if the difference score is lower or is negative, then the observations or observed scores are less than what was expected. And then if the difference score is positive, then the observed scores are greater than what was expected. So, for example, Apple, Baylor students reported use of Apple computers compared to the national market share contributed 68.6% to the chi-square score as the Baylor students had, and I'm going to do a quick calculation here, and I'm going to do equals 334 divided by 152, had 2.197 times as times greater frequency of using Apple computers compared to the national market share expected score. Conversely, we can just copy this, Control C, Control V. Baylor students reported use of Windows computers compared to the national market share contributed 31.3% to the chi-squared score, as Baylor students had, and once again we're going to take equals 146 divided by 326, had 44 or Baylor students had 44.8% Baylor students' use of Windows computers was only 44.8% of what was expected compared to the national market share expected scores. And so that's why using chi-squared for this is so important. It not only tells you that it's different, and using the percent chi-squared scores tells you where it's different. And frankly, there's really no point in doing number 6, and the reason why is because I just did number 6. So I'm just going to copy this. And I'm going to say the Baylor students' use of operating systems differs greatly from the national market shares and is easy to see, even with small sample sizes. And then I'm putting in the information there that we already calculated. And so chi-squared is a really phenomenal tool to say, hey, here's the difference, or there is a difference, and here's where the difference comes from. And so when you can use it for that purpose, it's got a lot of power. So I'd highly suggest that you get used to using this and use it as it is a very underutilized tool, because it can provide a tremendous amount of insight. Also, when you say here, Apple computers compared to the national market share contribute 68.6% to the difference between Baylor students and the national market share, as Baylor students used Apple products 2.1 times more often. Apple products with 2.197 times greater frequency compared to the national market share. And so just removing those little, chi-squared scores, things like that, make sure that you remove stuff that's not super easy. Same thing down here, national market share contributed to the difference, to the explained difference. There we go, difference. And so this is appropriate for the interpretation. So that's how you do that portion. Hopefully that was beneficial. Feel free to watch this as many times as you want. Also, there will be an example on this particular topic as well with the write-up for the write-up for the final project.